Hi everyone, welcome to the Lesson 12 Extra Practice ECON315 Guided Study Group session. So there's about 4 problems today and they're all pretty detailed, so I'm going to get started right away. Number 1 is about union wage advantage. So in an economy, there are 2 sectors, one unionized and the other non-unionized. Aggregate labor demand is LUD 150 minus 5W in the unionized sector, while labor demand is LND 225 minus 20W in the non-unionized sector. Labor supply is LNS equals 75 plus 5W in the non-unionized sector, and under the current union contract, the union wage WU is $10 an hour, and there are 100 workers in the union sector. So we can see from this paragraph a lot of good information that I'm going to have to write down. So number 1 asks, what is the equilibrium level of employment and wages in the non-union sector? And then what is the relative wage advantage for unions? So first question, equilibrium. We've been doing it the whole semester, so we should all be pros at it by now. So going to the whiteboard. They wanted it for the non-union sector, but I'm still going to write everything out. So LUD is 150 minus 5W. LND is 225 minus 20W. And then LNS is 75 plus 5W. They also told us that the wages for unions is $10 an hour. And currently the union sector has a labor level of 100. So equilibrium for the non-union sector. We can solve for equilibrium, We can solve for equilibrium by equating labor demand and labor supply because those are equal in equilibrium. So both of these are isolated for L. So we can do $225 minus 20W equals 75 plus 5W. So solving out for this, we can subtract 75 from each side to get 150 on the left, and then add 20W on both sides to get 25W on the right. And then dividing each side by 25, we get a wage of $6. As I said before, in equilibrium, we can plug this back into either equation since wage and labor are the same for supply and demand. So I'm going to plug it back into the supply equation. So labor equals 75 plus 5W. So we get L equals 75 plus 5 times 6, so that becomes 75 plus 30, and that gives us a labor level of 105. And again, this is just equilibrium, what we've been doing the entire semester, but I solved it out for you guys. So then the second part had asked, what is the relative wage advantage for unions? So that's just comparing the difference of wages between the 2 sectors to what the non-unionized sector is getting. So this is still number 1. So So I'm just going to label it relative wage advantage. And that, like I said, that can be found by taking the difference between the two. So the wages for unions is $10. The wages for non-unions is $6. So 10 minus 6 is going to be our numerator. This is, the advantage is going to be a percentage, but we have to set it up as a fraction. So it's going to be the difference in the numerator and then the non-unionized wages in the denominator. So this gives us 4/6, which we know is 67%. So what this number says is the union sector is earning 67% more than the non-unionized sector. It's a little hard to see at the beginning thinking about it in fractions and setting it up. But again, we're just looking at the difference between the two and then how that relates to the non-unionized sector wages. And like I said before, this number tells us that the unions are earning 67% higher wages than the non-unionized sector. So hopefully you're able to follow along with that. But that is number one. So number two says, as the current union contract expires, the union votes to increase its wage demand to W equals 15. How many union workers lose their jobs? So like I've said before, when we're looking at the hiring side, we're going to be focused on labor demand. So the unionized sector pushed up its wages to 15. So what we have to do is plug this 15 into the labor demand equation to see how many workers firms are demanding or how many they'd be hiring. So L equals, I'll rewrite that. LUD, labor demand for unions, is 150 minus 5 times 15. We know that that is 150 minus 75. So this becomes 75. And then they wanted to know how many workers lost their jobs. So we can see beforehand up here that the union sector had 100 workers. So if they had 100 and now they're only demanding 75, we can see that 25 workers lost their jobs. And that is all we needed for that one. So last part says, the workers who lose their union jobs move to the non-union sector as the reservation wages are all well below the wage in the non-union sector. What is the new equilibrium wage in the uncovered sector, and what is the relative wage advantage for unions? So what happens in part 3 is that these 25 workers who lost their job now move to the non-union sector. So this changes our supply equation because with the increase of workers in this non-union sector, that's increasing the labor supply. So what we have to do is change this equation. So LNS now becomes 75 plus 5W. And then we are tacking on those 25 new workers at the end. And then we can solve equilibrium the same exact way. So we can take this equation, 75 and 25 becomes 100. So 100 plus 5W. We can set that equal to our demand equation, which is 225 minus 20W, and then solve it out. So subtracting 100 from both sides, we get 125 on the right, and then adding 20W on each side, we get 25W on the left. Dividing each side by 25, we get a new wage of $5, a new equilibrium wage of $5 for this non-union sector. So they just wanted to know the wage, so we don't need to solve for the employment level. And then what they wanted to know was, what is the relative wage advantage for unions now? So we can solve this relative wage advantage the same exact way we did before. So in the numerator is going to be the difference between the two wages. So again, think back to part 2. Unions increased their wages, demanded an increase of their wages to 15. So the difference is now going to be 15 minus 5. And then put that over the non-union wages, which is 5. We can see this becomes 10 over 5, which is really 200%. So what this number tells us is that the union workers are getting paid 200% more than the non-union workers. I think the trickiest part in this problem is keeping track of all the different changes. But if there's a question like this on the exam, just go slow and check over your work, and I think you'll have no problem solving it out. So that was all of number 1, so we can now move on to 2. So this is about union bargaining. So it says, consider an economy containing a union and non-union sector. In the union sector, labor demand is 50 minus 2W, and labor supply is negative 15 plus 8W. In the non-union sector, labor demand is 60 minus 4W, and labor supply is negative 44 plus 12W. So calculate the initial equilibrium wage and employment in each sector, assuming the union imposes no demands on the firm in the union sector. So this problem is very similar to some of the stuff we did in the last one. So LUD is 50 minus 2W. And LUS is negative 15 plus 8W. LND, 60 minus 4W. And LNS is negative 44 plus 12W. And that was everything they gave us. So number 1 just asked for equilibrium. So once again, all of these are isolated for L, so we have no problem setting them equal to each other. Just make sure you keep track of which equations are for unions and which one are for non-unions. So I'm going to start with the unions. So 50 minus 2W equals negative 15 plus 8W. So this becomes 65 on the left and 10W on the right. So we can see that the wage is $6.50. And then non-union, this will be 60 minus 4W equals negative 44 plus 12W. So 104 on the left equals 16W on the right, and we can see that the wage is also $6.50. And then number 2, it says if the union insists on, oh wait, I didn't do half of it. Okay, so I found the equilibrium wage, but we still have to find the equilibrium level of employment. So going back to the unions, we can plug that into either equation since we're in equilibrium. So I'm going to plug it back into the first one. So L equals 50 minus 2 times 650. So 50 minus 13, we get 37. So 37 workers in equilibrium for the unions. And then for the non-unions, I'm again going to use the first equation. Again, this is where you really have to pay attention that you're using the right equations. So 4 times 650. And we can see that that becomes 34. Sorry about that. Didn't mean to skip over it. So now that we have both those, we can move on to number 2. So if the union insists on a wage of $10 an hour, how many union workers will lose their jobs? So the union wage is at $6.50 and now they're demanding $10. So we can see that with this wage increase, it's going to decrease the amount of workers demanded, and we just have to figure out how many workers. So like we did in the last problem, we just need to put this new wage into our equation and find out how many workers are being demanded by firms. So we can do LUD equals 50 minus 2 times 10. So we can see this now becomes 30. So if it was 37 and it's now 30, we can see that 7 workers lost their jobs. And I believe that's all of number 2, so we can move on to 3. So this is about market shifts. So consider 2 separate labor markets, one for skilled workers and one for unskilled workers. Both markets are initially in equilibrium, with labor supply equaling labor demand in each market, such that the wage for skilled labor exceeds the wage for unskilled labor. Analyze the impact of the following changes on the equilibrium wage in each market, the equilibrium level of employment in each sector, and the level of inequality. So this one doesn't involve any algebra, it's more conceptual, but I think the best way to solve this kind of problem is to graph it and look at it visually. So number 1 says an increase in the supply of unskilled labor and a decrease in the supply of skilled labor. So moving back to my whiteboard, it said there were 2 labor markets, so that means there are 2 different graphs. So I'm going to draw those out. We can label it wage and labor. And then it said both markets are in equilibrium such that the wage for skilled labor exceeds the wage for unskilled labor. So I can label these underneath as skilled and unskilled. And then when I go to draw this equilibrium, I can draw it in such a way that the skilled labor wages exceed the unskilled wages. So that's supply, demand, So just for reference, we can see that these two wages are definitely not the same. So this is what we start out with. This is our before number one. So number one then comes along and says an increase in the supply of unskilled labor and a decrease in the supply of skilled labor. So this is going to be our market shifts, which is what the problems are titled. So what we can do is show how each of these shift and then analyze the three things they wanted us to look at. So an increase in the supply of unskilled labor is going to move this to the right. And then a decrease in the supply of skilled labor is going to shift this one to the left. And then with this shift, we can see there are new points for wage and level of employment. So the first thing it asked us was analyze the impact of the following changes on the equilibrium wage in each market. So we can see, so I'm going to label this skilled and unskilled. So in the skilled market, this left graph, we can see that the equilibrium wage increases. In the unskilled market, we can see that this equilibrium wage decreases. Number two is about the level of employment. So going back to the left graph of skilled, we can see that the employment decreases, but in the unskilled market, the employment increases. And then finally, it says the level of inequality. So this means the inequality between wages. So this is where you need to look at the two graphs together. So beforehand, the wage difference was this portion here. I made kind of like an eye shape. But now the wage difference is here. It's kind of hard to see. I'm just lining up where these equilibrium points are. So what we can see is that the inequality actually increased. So it's a little hard to see sometimes, but hopefully you're able to follow along. I think the best way to look at this problem is to graph it. You can do it in your head if you want, but I'm a visual learner, so that's my recommendation. But anyway, part two is the same thing, but they give us another scenario. So I'm going to draw two more graphs underneath this. And again, it was the same exact initial scenario of them being in equilibrium and the skilled market having higher wages than the unskilled. So then we can see on here that the inequality starts out about here. But anyway, this time it says an increase in the demand for skilled labor and a decrease in the demand for unskilled labor. So an increase in the demand for skilled labor is going to impact the left graph. So this demand curve is going to shift to the right. And then a decrease in the demand for unskilled labor, that's going to be a shift to the left. when looking at curve shifts for supply and demand, I like thinking of it as left and right rather than up and down. I look at going to the right as an increase than going to the left as a decrease. It's easier for me to understand that way. But anyway, we can see what these changes do. So we have these new demand curves, which means new equilibrium points. Also, like on your exams, as you learn by now, labeling everything is really important. But anyway, looking at each of these. So we have skilled, unskilled. So for the skilled wages, we can see that they increased. For the unskilled wages, we see that they decreased. For the level of employment, we can see for the skilled workers it increased. And then for the unskilled workers, it decreased. And then finally, for inequality, it was initially this wide, and then we can see it's also increased. So in both scenarios, the inequality increased. That doesn't mean that it's going to increase all the time. It just depends on the scenario. So if you haven't heard it by now, I would say for this last exam, it's important not to memorize things. It's way more important and beneficial if you really understand things, which is why I think looking at it through graphs is beneficial, because it's easier to see on paper in front of you rather than doing it all in your head. So one of my number one pieces of advice is to not try to memorize things. It's only going to mess you up in the long run. But anyway, this problem was a really good example of how you can use graphs to help you when there's no algebra. Okay. Anyway, that was all of number 3, so we can move on to 4. So the last one, 80-20 ratios. So consider part 2 of the previous question in more detail. So now we're actually going to put some algebra into what we just did. So for the unskilled labor market, LUS is -10 plus 20W, and LUD is 170 minus 10W. So for the skilled labor market, LSS is -40 plus 20W, and LSD is 235 minus 5W. So they give us the unionized sector, no, the skilled and unskilled workers. This one's different. But number 1 and 2 are both equilibrium wage and employment. So like I said earlier, we are all pros at that now. So I can go over this pretty quickly. So LUS is -10 plus 20W. LUD is 170 minus 10W. Labor for skilled workers is -40 plus 20W. And labor demand for skilled workers is 235 minus 5W. So number 1 was equilibrium for the unskilled workers. And as we've seen before, all of these are isolated for L, so we can easily just set the two equal to each other. So this is going to be with the top row of equations. So -10 plus 20W equals 170 minus 10W. Solving for this, we can see it becomes 30W equals 180, and then dividing each side by 30, we get W equals $6. And then plugging it back into either one, I won't forget this time, we get L equals, I'm going to use the second equation, so the demand equation, 170 minus 10 times 6, so 10 times 6 is 60, 170 minus 60 is 110. So we can see that in equilibrium for the unskilled workers, wages are 6 and level of employment is 110 workers. Moving on to 2, it was equilibrium for skilled workers. And this is going to be the second row. So negative 40 plus 20W equals 235 minus 5W. So this becomes 25W equals 275, and then dividing by 25, we get a wage of $11. I'm plugging it back into either one. I'm going to use the second one again. We get level of employment equals 235 minus 5 times 11. 5 times 11 is 55, so 235 minus 55 is 180. So then thinking back to our graph, we can see that the wages for skilled workers is greater than the wages for unskilled workers. So it satisfies what they gave us in number 3. But anyway, moving on to part 3 of this problem. It says, suppose labor demand changes in each market. So for the unskilled labor market, LED is 140 minus 10W, and for the skilled labor market, LSD is 285 minus 5W. So calculate the new equilibrium wage and employment in each sector, and that's all. So I'm going to start with unskilled. So they told us that labor demand changed to 140 minus 10W. And then we can set that equal to what our supply equation was, because that didn't change. So that was negative 10 plus 20W. So this becomes 150 equals 30W. So we see that wages are now $5 in equilibrium. I'm going to plug this back into the new labor demand equation. So we have labor equals 140 minus 10 times 5. So 140 minus 50 equals 90. And then for skilled workers, they said that the labor demand equation changed to 285 minus 5W. And that is set equal to the supply equation for skilled workers, which is negative 40 plus 20W. So this becomes 325 equals 25W. Then dividing each side by 25, we get a new wage equal to $13. And then like we did for the last time, I'm going to plug it back into the supply equation. So L equals negative 40 plus 20 times 13. So 20 times 13 is 260. 260 minus 40 is 220. So that is everything we needed to do for these first couple problems. It was all equilibrium, dealing with those shifts. So exactly what we did in number 3, but instead of looking at it visually and conceptually, we're doing it with math. So if you remember from number 3, we said that inequality increased, and we can see that in here because originally we have wages of $6 and $11, which is a $5 difference. And now we have wages of $5 and $13, which is an $8 difference. So we see it proven that inequality did increase. But I think it's cool to look at it and how the two cross paths. But anyway, number 4 says calculate the percentage increase in wage inequality using the 80-20 ratio, assuming that the skilled market represents earnings at the 80th percentile and the low skilled market represents earnings at the 20th percentile. So 80-20 ratio is a fraction. So what they're saying is, looking at this fraction, the numerator, or the 80th percentile, is going to be the earnings in the skilled market, and then the denominator, or the 20th percentile, is going to be the earnings in the unskilled market. So using these ratios, they want to find a percentage increase. So the percentage increase equation, percentage change equation, is going to be whatever new values you have, any kind of new value, new number, subtracted from the old value over the old value. So kind of what we did with the relative wage advantage, but in a different sense. So comparing the difference between new and old wages and comparing that to the old wages to see how much they increase by relative to the old wages. Hopefully you're able to follow along with that. But anyway, each of these terms in this equation, these 3 terms, are going to be in this 80-20 ratio format. So we can see that this percentage change is going to be, so the new 80-20 ratio is 13 over 5 because it's the skilled wages over the unskilled wages. And then we subtract the 80-20 ratio for the old wages that we had before these shifts. So the old skilled wage was 11 and the old unskilled wage was 6. And then we can put that over 11 over 6 again. So like I said, I'm following this percentage change formula, but each of these terms are going to be the 80-20 ratio format. So we have the new wages and then the old wages. And then we just need to solve this out. So you could easily plug this into a calculator, or you can solve it by hand. By hand, what you could do is multiply the entire thing by the least common denominator, which in this case is 30, because 5 times 6 is 30. So then I like getting rid of the fractions, so that's why I multiply it all by 30 first before I solve for it. So what this does is get rid of all the fractions, so this becomes 13 times 30 over 5, because you have to distribute this 30 to each term. So 13 times 30 divided by 5 is 78. 11 times 30 divided by 6 is 55. And then we know that this is the same fraction, so it's also 55. So those numbers are a lot easier to work with than these fractions. So 78 minus 55 is 23, and then 23 over 55 becomes 41.8%. Sorry, I crammed this all in on the side. Hopefully you can read it. But anyway, by using this 80-20 ratio in the percentage change formula, we can see that wages increased by No, the percentage change in wage inequality is 41.8%. And it's a positive change. So I believe that's all the problems for this week. A lot of equilibrium. Very similar to like the first couple weeks of the course when it was a lot of equilibrium. But going a little more in depth with applying it to graphs and a couple fractions and percentage changes and things. But I think that you'll be able to follow along pretty easily in this video. You know, if you have any questions, but best of luck in your studying and have a great week.